So you're probably sitting there thinking to yourself, well, that's all the food, so what's Miss Reed possibly going to blabber on about in this video? Well, I'll tell you about my weekend. This weekend I went to Taos, New Mexico. I told you about the food I had. It was awesome. But I went down there for a motorcycle event. I ride motorcycle trials. It's the coolest thing in the world. And not only did I have the best weekend ever, I also won. So these are my trophies. I won this trophy this past weekend right there. And I won this trophy the last time I was down there in the beginning of the summer. So yes, your teacher is the coolest person alive. Alright, problem number 8. That's a lie, I'm a huge dork. F of x is the cube root of x plus 1 plus 4, g of x is x squared plus 2, and h of x is defined as the composition f of g of x. So let's find h of x. So h of x is taking g of x, putting it inside f. So f is eating g, so we will get the cube root. Instead of writing x, well, hold on, let's just do this. Plus 4 plus 1. So notice that I've written h of x, except I have not written an x. Instead of x, I'm putting in g of x, which is x squared plus 2. But those parentheses aren't really doing anything, so let's simplify this. This will equal the cube root of x squared plus 3, and then I have a plus 4 on the outside. That is h of x. And now let's do b. Find h inverse of x. Well, what do we do? Well, h of x can be written as y, right? It's like saying y equals the cube root of x squared plus 3 plus 4. And if we want the inverse, all we need to do is swap x and y. So x equals the cube root of y squared plus 3 plus 4. And now let's just solve this equation for y. So what do you have to do? Well, first you have to subtract 4. So we get x minus 4 equals the cube root of y squared plus 3. Well, we're trying to get y, so what do we need to do now? Now we need to cube things. So x minus 4 cubed equals y squared plus 3. We've almost got y, but we've got that pesky plus 3. So x minus 4 cubed minus 3 equals y squared. Almost there. Finally, y equals the square root of x minus 4 cubed minus 3 right there. And that is our h inverse of x function. Now, technically, should we have a plus or minus? Yes, but that would make it not a function. So we're just going to ignore that and focus on the principal square root, just the positive piece. So state the x values where h of x equals h inverse of x. That is saying find the x where, I don't know why I'm writing this, where they intersect. That's what that's asking you to do. Anytime you see something equals something else, graph each something separately, find their intersection point. So, graph them. Graph them both. Find their intersection point. If you're on an old school poopy calculator, how do you do this? H of x, I would enter that as, let's call that y1. Let's say y1 equals, I would open a parenthesis. I would say x squared plus 3. I would close my parenthesis. I would do caret. I would do the power of 1/3 like that, and then I would do plus 4. If I'm doing h inverse of x, I would put that into y2, and I would put that as an open parenthesis, another parenthesis, x minus 4, close my parenthesis, cube it, subtract 3, close my parenthesis, raise that to the power of open parenthesis 1/2. That's probably obnoxious though. You could also do it as your square root thingy like that. That opens it. Then do a new parenthesis, add a first parenthesis, x minus 4, close parenthesis, caret 3, minus 3, close parenthesis, and that does it right there. So either way you enter those in, totally totally cool. Totally up to you how you want to do it, but one of those two. If you do other things, you might be goofing it up. There's also a cube root button, math, and then option 4 is a cube root. But if you have the new fancy calculators, you can make it look a lot better, and you don't need to worry about all this nonsense that we're doing right here. So find the intersection point, hit a zoom 6 for a standard window. Start there and see what it looks like. When you graph this with a zoom 6 standard window, you're going to get something that looks like that, and then a little like blue that looks like that. And if we had that negative version as well, it would just, oh, not like that. It would just kind of like give us a like little thing like that as well. It should be a perfect reflection over the line y equals x. Again, you're not going to see that bit right there because we're only graphing the positive bit. But we are finding this intersection point. So hit second, hit calc, which is the trace button, second, calc, and we want option 5, which is intersect. It will say first curve. If you only have 2 graphs entered, hit enter. It will say second curve, hit enter again. And then it's probably not going to have done anything, and it will still say second curve. If you look and it says x equals 0, y equals nothing there, it's because this graph, this second graph, this pink graph right there, is not defined for x values over there. So hit the right arrow over until your y values appear. Then you'll be on the graph, then you can hit enter, then you can hit guess, getting it close to that intersection point, and then you can find that x equals 8.09. I'm going to call that 1. Now, here's the deal. Since this is the intersection between a function and its inverse, x and y have to be the same value for that intersection point. If they're not, you done messed something up.